we're going to take a quick look at why completing the square works in terms slightly different than those I might have used in class. Okay, so let's start with this. X squared plus 10x, I say is the first part. I really mean is the first two terms, but we'll see what I mean by that. Is the first part of the quantity x plus 5 squared. Now don't read what I said here, but square x plus 5, pause the video, square x plus 5 and see what you get. Okay, you should have done that without looking at what I got. But x plus 5 quantity squared, as you should be able to easily verify, is x squared plus 10x plus 25. What do I mean by the first part of this? Well, we're looking for x squared plus 10x, and right there it is. It's the x squared and the x term of the square of x plus 5. Okay, see if you can do this one now. X squared minus 14 is the first part of what? Pause, do it without looking. Okay, well, I say it's the first part of the quantity x minus 7 squared. If you didn't get that, square this before you look any further. If you look, you're going to ruin your chance to understand something. Okay, of course, you get to look. Okay, you get to look now. Hopefully you paused and did this. And hopefully what you got when you squared x minus 7 is x squared minus 14x plus 49. And what I mean again by the first part, is here. And it matches what you have here. Okay? Now, do this. X squared plus 18x, I didn't give you anything to look at. Stop, do this, and see what you get. Okay, well, hopefully you did that, and hopefully you said, well, that's the first part of x plus 9 squared. Now, how do you get the 9? Well, if we notice, there's a pattern here. 5 is half of 10, negative 7 is half of negative 14, 9 is half of 18. And if we square this, what do we get? We get x plus 9 squared equals x squared. Now, if you use a special product formula, you know x plus a squared is x squared plus 2ax plus a squared. So the 2ax, a is 9, and 2 times 9 is 18. So it's plus 18x, and that's plus 81. And of course, you should be able to square this just by writing x plus 9 times x plus 9 and using the distributive law. So you should understand how to square this. It's a special product, but you should also be able to square it easily using the distributive law and see very specifically where that 18x comes from. Okay? And again, this is the first part, and that matches this. Okay, now what about x squared plus bx? What are you going to do with this if you follow the pattern of what we've seen up here? Pause, see if you can do this, see if you can make an attempt. Well, in every case, the number we put here was half of the coefficient of x, and it worked out. When we did the square, we got exactly what we should have. And again, by squaring these binomials, preferably using the distributive law, you understand why this number has to be half of this number, because this number is going to be double this number. Okay, so we're going to do the same thing here. Okay, it's x squared plus bx. We're going to square x plus b over 2. And that's because x plus b over 2 squared is, and I'm going to write this out, and I'm going to not write out all the details, but I'm going to allude to the distributive law, is x times x, which is x squared. B over 2 times x is, well, b over 2 times x. And then we multiply through by the b over 2. X times b over 2 is b over 2x. b over 2 times x, of course, is b over 2 times x. And b over 2 times b over 2 is b squared over 4. And that equals x squared plus bx plus b squared over 4. And the x squared plus bx, of course, is the first part of this. And instead of first part, I could have written first two terms, which would have been mathematically more correct. and more specific, but you should understand what I mean and why this works the way it does. Now, if we return to the situation of our first example, x squared plus 10x is here in the square of x plus 5. Putting parentheses around just the x squared plus 10x, and then isolating 25, we have the same equation we have here. Subtracting 25 from both sides tells us that x squared plus 10x is the square of x plus 5 minus 25. Now, what analogous statement can we make for the second example? Okay, I'm going to write that down. You should pause. Well, by analogy with what we did up here, this tells us that our x squared minus 14x added to 49, which is just this, has to be equal to x minus 7 quantity squared. So x squared minus 14x is quantity x minus 7 squared minus 49. So in any situation, if we have an x squared minus 14x, we can replace it by quantity x minus 7 squared minus 49. Okay, let's see what we can do with the third example. Hopefully you've paused, but now I'm changing the way I state this. I can say x squared plus 18x can be replaced by what? Think that through. Okay, well, we can replace that by x plus 9 quantity squared minus 81. Because we could write x squared plus 18x plus 81 equals x plus 9 squared. Therefore, x squared plus 18x is x plus 9 squared minus 81. What can we do here? Okay, so I say x squared plus bx can be replaced by what? Well, it's going to be replaced by the quantity x plus b over 2 squared minus b squared over 4. Why is that? Because x plus b over 2 squared equals x squared plus b squared over 4. Just square this and you get this. So this squared equals this. So if we subtract b squared over 4 from both sides, we end up with x plus b over 2 quantity squared minus b squared over 4. Just to see a quick application of this, let's solve the equation x squared minus 14x plus 6 equals 0. Now, what can you replace? And I never know if this camera is really picking up the top of the screen, so let's go up here. Let's replace x squared minus 14x with the appropriate expression. Well, we've seen that x squared minus 14x is x minus 7 quantity squared minus 49. So we replace this with this. We still have our plus 6. We still have our equal 0. Now we rearrange that. Of course, we do the subtraction. We get minus 43 here. And we end up with x squared minus 7 squared equals 43. What's our solution? Well, I don't have room to write it all out, but we've seen this sort of thing. And maybe I have room to write at least part of it. This tells us that x minus 7 is plus or minus the square root of 43. Let's write that down correctly. Hate that smudge, but we'll have to live with it. So that x equals 7 plus or minus the square root of 43. Now that 3 is kind of hard to read, but you should be able to complete the solution from here, because this is something we will have already talked about by the time you see this video. It takes no great leap of faith to understand then that any quadratic equation we write down, we can complete the square on the x squared and the x terms, and having done so, replace that with a perfect square and plus or minus some number. It'll always be minus. And then translate the equation into this form and I do have an error there. Let me fix that. I wrote a square on this x, and it shouldn't have been there. Hopefully you picked that up when I did it, and we're a little confused. So if you get a little confused by a step, always look ahead to see if I had to correct it. Anyhow, you get something of the form, some quantity, linear quantity involving x squared is equal to something, and then that becomes very easy to solve. So again, we can always do this with a quadratic equation. Of course, you're going to have a negative here, and if your number here is too big, if you have a positive number here that's too big, then it's going to end up bigger than the negative term. So when you subtract it from both sides, you're going to end up with a negative over here. And of course, if you end up with a negative over here, you can't solve it. That just means that your quadratic equation has no solution.